while working with it. Like for example, if you've got carpet in your house and it's wintertime, like it is right now, everything's very dry. The humidity and moisture level means that surfaces will build up a static potential on them a lot more easily. And so if you're working with something a lot and handling it with your hands a lot and you're on carpet, it may suddenly stop working after a couple of days of doing that. And you may not, and it may not be obvious why it failed. So anyways, I pulled it out and was looking at it. I was like, this is neat. And I have a soft spot for this project because this is one of the first ones we did. Very, very long time ago, it feels like. So I'm ready to go if you guys are.
Looks like the bracelet should measure up.
It does. It actually doubles as a measuring tool, although it's kind of hard to see. I think it's literally like a Harbor Freight. There's actually a couple of what it is it's actually a combination of a couple of like instructables about how to make your own slap bracelets by taking a piece of ruler and basically bending it backwards, and then taking that plus conductive silver impregnated fabric, which you can get for online for a reasonable cost, and then you like buttons for garments. There's a certain size of button that actually fits all of the ESD clips, and so you combine all those things together into ESD bracelets. The only thing is that when you make your own wires, you have to add in a 1 megohm resistor, so you don't electrocute yourself when you ground out your cable, and then you touch something that may be live. So, yeah. Anyways, so I've got the soldering iron set to 750 degrees F. I've got, and James, you may have to remind me what the pinout is for these devices. I've stripped all the wires, which you can't see because of autofocus. So what I'm going to do is I'm going to pre-tin all the wires. If you do this with a breadboard, that's perfectly acceptable too. What you can do then is solder on the pins, and then when you get done with it, just solder directly your wires onto the pins, and that's totally acceptable as well. Now I wish I had some handy.
I do want to ask one question. So the larger of these two devices is the BME?
The more feature rich is the BME.
Okay.
And so the way, I think, Alex, were you talking about the two devices he has on camera?
Yes.
Yeah, the larger of the two is the Wemos D1 Mini, which is a developer board for the ESP8266.
Okay.
Which is the microcontroller that is used for doing the Wi-Fi and interaction with the BME.
Okay, gotcha. Thank you.
Okay.
And then the BME, if he has a chance to show you, is actually this tiny piece on that bigger purple board. I don't know if the autofocus will work, but
nope.
Could make out the Ada fruit
That's
label, I think. Maybe.
What was that, Alex?
Did you guys get it from Ada? Oh, there it is. Yeah, nice. Pretty cool.
Yeah, these all came from Amazon, and unfortunately, we were dealing with the Amazon listing descriptions, which were poor, to say the least. So I got a link for it, but there's basically there's two different versions, and on top of that, there's different variations of those versions. The important thing, though, is that they'll all work. But some versions don't have humidity, is what I think it comes down to. And humidity is kind of useful for weather and environmental stuff. So that's kind of a bummer. But I need flux. So do you have any questions while I'm doing this? Or any more questions?
So you're just melting a bit of solder onto the tips of the wires you're going to use to to solder into these pins?
Yes. And the reason why you do that is for ease of use. So what happens is that if you're using, what I'm using is I'm using like spare wire that I scavenged from from another project or another piece of electronics that I kind of harvest parts from occasionally. And it works really well, but you kind of are at the mercy of wherever the device was originally manufactured for things like how much flux it had on it, what the quality of the cable or the cable is, things like that. So I'm about to, I'll pull out the camera and show it, but the process you normally go through is you basically put a little flux on your, maybe better lighting in here, but this is flux. This is a little Radio Shack flux. This is the good rosin stuff, which has a great smell to it. And what you literally do is you, I don't apparently, is you just kind of poke it in there. My soldering iron already has some solder on it. I'm using lead-free because I don't like dealing with lead if I have to, and it just makes a nice shiny coating. And so you just kind of hit both sides, run some solder on it. And what this, and pre-soldering like this does is it makes it a lot easier to get flow when you insert it into the board. It's not necessary, but if you ever shove one of these into the boards, what happens is that the cable can fray, and that can cause it can cause more difficulty than it's worth. So these should all, I'm using pretty small cable to begin with. And so I shouldn't have any problem with like overfilling having too much solder on these devices or on these wires. So what I'm looking for is basically kind of like nice, clean, shiny, no solder kind of on the, or no solder kind of like poking off of it, and nice quality flow across the entire piece. This rosin is not very good to breathe in. It's a irritant. So either hold your breath, stay away from it, or they actually have another project where you can get a really nice solder fan, which will blow the solder fumes away from you. It's not toxic, but it's an irritant, and it can cause lung damage over many years of use. So it's one of those things like kind of like paint fumes. You may know what they smell like, but you probably shouldn't know what they smell like. But it won't kill you. It'll just be one of those things you probably don't want to do on a regular basis. So I tinned all these, and they look pretty good. I don't know if you can see very well what I'm doing, but I'll zoom in on them, see if that helps a little bit. So I've got 4 colors here. I've got orange, gray, got orange, gray, blue, and purple. Yeah, you can see here. And so what I'm going to do is I'm going to use the blue, and well, actually, I usually like to use brown. Well, actually, this one. So I'll use the gray for ground in this case. And what I do is I usually just kind of like give it a little bit of a tap on one direction so it stays in place. And I'll use blue in the other for power. And then I'll use purple for SLC or SCL. And I'll use orange for SDA.
Does SCL stand for clock?
Yes.
Okay.
It stands for serial clock and serial data. And this is for the I2C version of the communication protocol. Different versions have I2C and SPI. The only difference between I2C and SPI is that the I2C uses 2 pins for data and clock, where SPI uses 3 pins for data, clock, and select. Yes, and they both use power and ground. And also, I take it back. SPI uses MISO, MOSI, and clock, as well as a select line. So what the difference is that the SPI interface, the serial parallel interface, is a little bit less complex on the software side, where the I2C is a little bit more complex, but it uses fewer pins. So I bunged this. This is a little messy. You can see I made a short there. So what I'm going to do is I'm going to come back with a pair of clippers. I'm going to clip the ones that I got correct. And I'm going to go back and then desolder them. So you can kind of see, I kind of shorted out the 2 pins in the middle. So I got these 2 correct on this edge. So I'm going to clip that one and clip those 2. And then, well, actually, I can just clip them both right now, and then I'll just clean up the solder, whatever's left. So by clipping them, I actually broke the solder joint, and it actually looks pretty good. So this guy's ready to go on to the next phase. Any questions? Oh, we got a thumbs up. Awesome. Okay. So this is the Wemos that we're using. There's 2 sides to it. Depending on which version you have, will depend on what it looked like. You have to go by the labeling, which is on the side here. So we're going to basically tie, this one's going to be only used for weather sensing. So I'm not going to basically worry about making it reconfigurable. If you use a breadboard and plug the wires in, you could set it up for this weather sensing project, and then you could break it down and build it up for a myriad of other projects. Like we had a LED plant project that uses the same Wemos, but then uses a NeoPixel style LED to make the pixels turn off and on. In this case, we're going to use this just for this application. So we're just going to solder these in directly. The easy ones are the ground pin, which is G, labeled here. Blue is power. So gray is ground in this case, and we're using 3.3 pin, which is blue. And we'll do these 2 first. And James, if you'll help me out on what the pins for SDA and SCL are, I'll get to those next.
I'm just jealous how good you can solder on a camera hanging above you, where I had all the perfect situation and my solder is just like, I didn't even want to show it on my camera.
Takes practice.
I think it takes practice to make it look like this. Oh my gosh. I've ruined so many Wemos because I did the wrong wires and I can't get it back out, and I destroy it.
There's definitely an art to it, and I'm not even that great. I would say that I am passable. So once you get it done, again, you can actually use toenail clippers if you don't have these fancy clippers, but you just go in here, you just go clip, make it nice, all nice and pretty. And so what we have here is we've got power, ground, attached to the device. So I'll just pull my hand out of the way. And now for the next part, where am I going now?
Not necessarily the right way, but I had D4 to clock and D3 to SDA.
So D4 is right here. So in this case, D4, SCL to D4, so purple, and D3, which is right next to it, which is going to be orange in this case, which is tied to SDA. One thing to note about the this Wemos and the way they did these is that you'll find that on Arduino projects, they'll call out different data I/O lines. Those data I/O lines do not necessarily have the same label as these. So, for example, I believe these are, I'd have to go look it up again, but they basically have different GPIO lines, which just stands for general purpose I/O, versus this labeling, which is D4 and D3. It gets really confusing because when you go to try to follow the directions, if you follow markings on the board, it can be different than the Arduino I/O lines that you thought you needed, and that requires a whole bunch of rework sometimes. The nice thing about the ESP line of devices, though, is that all these pins are remappable. Not all microprocessors have remappable pins. So, for example, and not all pins have the same feature sets. So usually, like the A to D controller portion is only available on certain pins. Same thing with serial and high-speed serial and high-speed A to D and D to A conversion. But for SPI, which we're doing, it shouldn't really matter too much. So we've got this thing wired up now. I can zoom in, see what it looks like. Come on, take these focus here. Okay, autofocus, do your job. There you go. So we got these soldered in. We cut the leads. They look pretty good for the most part. And now what we'll do is we'll kind of like take these leads and like give them a gentle twist to kind of keep them all together. And so at the end of the day, that's what it looks like. And now for the next part, we take this whole mess and we get into our Arduino platform. So I'm going to disconnect and rearrange things. So forgive me as the things get a little crazy on the video. James, do you got anything else on how you use this with Home Assistant?
Yeah, I can share a screen and show how I'm using it. Just give me one more here. All right. Let me see here. So I know several of you may not be familiar with Home Assistant, but I feel like for many of you, you get tired of hearing me talk about it. But oh goodness, this is disappointing. I think I unplugged it, so it's not showing up online. So this is my within Home Assistant. You can add add-ons. They're very simple to. It helps it be a lot simpler to run a bunch of different add-on tools. And so when like I mentioned earlier, I originally went with Tasmodo, another framework for using ESP8266, is where you don't have to deal with the headaches of interfacing with the devices. So ESP Home is very similar, except it takes a more of an automated approach, in my opinion. And so you can see here, this is a view of 5 ESP8266 devices that I have across the network. Some of you will recognize the marquee scroller that we did as a project, maybe what was that, a year ago, maybe more. I've since integrated it into ESP Home and blew away the firmware on it. But this particular one here is the device that I showed you on the camera, which I don't know if you can see me at the same time, but all I had to do is, instead of dealing with all the fun that, oops, I hit the wrong one, didn't I? Ignore those passwords. I haven't migrated everything into secrets. Besides, it's a guest password. I have it on a guest wireless for IoT. But anyway, the nice thing about the ESP Home, especially once Lawrence shows you some of the stuff that he's going to do, you are going to share your screen when you code it, right, Lawrence?
Yeah. I'll show.
So this shows you how easy some of this can be. So you can do some of the stuff on Arduino, but this way I can make changes on the fly and then push them out using the ESP Home framework. So I used the Adafruit library and used the Arduino IDE and messed with it originally. Then I moved it to Tasmodo, which had its own benefits. But finally, I wanted to integrate it into here. So it's just a simple YAML file. I say simple. There's a generalized section here at the top that all ESP Home devices use. One to tell it what platform, which I say it's a ESP8266 with the dev board of D1 Mini. You tell it what Wi-Fi you want it to connect to. You give it a fallback hotspot in case your Wi-Fi is dead, so you can get back into it. You set up an API access so that your Home Assistant can talk to it. But then this is the nice thing, is it makes it easier when you make a mistake on where you solder things to. Like if I had accidentally soldered D5, I could have easily switched it to and mapped it to. And that's why I was warning Lawrence. I don't know if I can't remember with this particular one if it's wired the right way. He may have to make some special modifications on the code on his end when he goes in. But the nice thing is, I come in here on the sensor itself, and I can add some tags, categories to it, and tell it what types of information I can gather from it. And so you can see here the temperature, the humidity, and the pressure are all able to be collected. This is the address from an I2C perspective, I2C, I guess, however you want to refer to it. And then I tell it that I want to get the data from it every 15 seconds. So probably way too long, too frequent, but that was just, I haven't gone back and touched this one. And some of the cool stuff is, if you've got temperature and you've got pressure and you've got your altitude, you can actually, so if I had this on a moving device, I could actually have it calculate altitude. It actually calculates altitude and feeds that as another metric that gets fed back into Home Assistant. And then here's a formula that somebody shared to create the absolute humidity from the data that's being read from it. And so ultimately, this is all that's needed to get all this data out in a standardized format from the device regularly. Like I said, every 15 seconds, I forgot. And just like this, just doing an upload, it goes out and pulls on all the libraries for the ESP, compiles it on the Home Assistant server inside a container, and here it is uploading it to the device. And so if I'd made some changes to the YAML that quick, it's got the new program, and via Wi-Fi, it's gone onto this device. And so the cool thing by using Home Assistant for using these sensors, I feed the data back into its database, which I've reappropriated in a Flux container to do that. And then that means I get to have all sorts of visualization tools for it. So you can see here, it's calculated that I'm at 264 meters above sea level. It says temperature is 21.8 degrees Celsius. On some of my devices, I haven't been very standard. Some of them I convert from the ESP home into Fahrenheit, and then though I don't have to do another conversion in Home Assistant. In this one, when I set it up, I did it in Celsius, and then I have to convert it within Home Assistant to look at it in Fahrenheit. But like I said, I did this conversion maybe 6-7 months ago. Haven't touched it ever since. I put it up in my attic until it melted in the summer. And it actually started reading intermittently. I think the Wi-Fi on the ESP was not very happy about the temperature. And so I had some interesting patterns there, and you can see those here in a second. But let me see here. If I go into Grafana, I've got a test dashboard that pulls in just some random stuff from the Influx database. And so you can see some just random stuff. But here's a couple of the temperature sensors that I have that I was playing with. I've got all of them in another view, but here's the BME. You can see that I've been handling it. I moved it out from where it was, and so you can see the temperatures come up since based on probably just my hot air just breathing on it. You can see the humidity when I was holding the sensor, and I had the moisture in my hand just alone was able to shoot the humidity up. I mean, it's not a whole lot, right? It's just a couple, but anyway, the nice thing is once the data is in the database, I can do whatever I want with it. Like in this case, I have it plotted against various other sensors. One of the things that you might have seen on the ESP Home was a BLE, ESP BLE, and it's just a device that, again, I don't know if you can see me while I'm sharing my screen, but I've got all these little devices that I put open source software on. And so I've got one little development board, kind of like it's just a slightly different version of what Lawrence was having, that collects via Bluetooth all the broadcasts of this. And so that's what you're seeing with I'm testing different ones. So that's why you see two different names, master bath and master bathroom, because I was thinking it'd be interesting to see how much the humidity shoots up during showers and stuff, and whether or not to turn vents on. It was just a play of an idea. But are you ready, Lawrence? You want me to stop sharing?
Yeah.
Okay, good. I was just killing time for you.
Yeah, thank you. Appreciate it. So I tried it and it didn't work. But let me show you how it doesn't work. So let me see if I can share my screen. Let's do this. Okay. So you can see here, what I did is the default, okay, so this is what it says when it doesn't work. So it says it couldn't find the valid BME 2800 sensor, check wiring address of sensor ID. And so I was checking the online forums, and it says that they suggest using the default pinouts for the Wemos SPI and SLC, which are different than what James used. So we're going to show how to desolder wires and put them in a different location. So bear with me.
Wait, what's making you say it's on the wrong ones?
Well, for one, it didn't work, and for two, let me share the screen where I found this nice little link. If I can get back there. Okay.
But I wouldn't, just in case, check this out. I don't know if you saw the address that I use in YAML. I think I ran into this as well. And I think
which address do you use?
I pasted it in chat. So I used 76, hex 76. Because I was having, in fact, I think I even used the Adafruit library to track that one down, because it said the default address is 77, which is, but their particular board was on 76, and they used an I2C scanner to figure it out. And so I just changed mine. Of course, this is like I said, this is like over a year ago when I first set it up.
Yeah, so this is one of the nice reasons why you would breadboard all this first before committing to soldering. So 76 is the listings for the device. Let's see if
But your Adafruit output, or your output that you showed, didn't show it scanning for 0x76.
Correct. It did 60, 61, and 58.
So
So you're saying 76.
Yeah.
Where would I put that? Oh, sensor ID 16. I see. Well, that's just the sensor ID.
if you look at the code,
Oh.
it has, you would, did you find it?
I see. There's a one line change that I have to make. Is a let me see if this works, then we'll go from there. Wire 2 is not declared in the scope. Okay.
Lawrence, what was that window that you were using that it looked like Arduino, but is it like an Arduino terminal or something or?
Yes. Let me see if I can share my screen. I can point it out. So if you click this button on the top right here, is labeled serial monitor. It opens up that window that you saw, which is, it opens up the serial monitor, which gives you a serial output. And so when it declares the serial begin 9600, that is the baud rate that you select in the window.
Thanks.
Okay, so I guess I got two options at this point. I can either debug this or I can resolder it to match the settings. Either way, it's gonna be
Well,
dicey.
Well, I mean, if you, all you have to do is change the pins in your code to match, you don't have to resolder. What it's not doing is finding it. So, right? Because see right there above where it has the pin settings for the BME, CS, and for the clock.
Yes. So that means that for the Arduino page, I need to match up the, let me see, Adafruit is using the for I2C, the SCK is the SLC pin. So SDK is here.
Does anybody have their handy dandy Wemos mapper?
I mean the page.
The pin out so that you can match it back for Arduino.
Yeah. So that's where I was getting the, maybe I had the wrong location. Yeah. So if you just look for Wemos D1 mini pinout Arduino on Google Image, you'll get like thousands of them because everybody has their own flavor. But we're on D4 and D3, so GPIO 0 and GPIO 2. So if things work like we expect, which they don't always, this should be, and SCK in this case is tied to SCL, SDK.
D4, which would be
I used pink or purple, and that would be D4, yes.
so that would be 17.
17.
At least on one of the many images of pinout mappings, right?
But that's GPIO 2.
Oh, gotcha. My bad. Oops.
So we can try. The nice thing about doing code is I can change and try out different things too, without jumping into the stuff. And so it also says here that they're using SDA for SDI. So SDA is So a little bit of history. SDA is because of originally SPI was based on a master and slave nomenclature. A lot of people have moved away from that. So and they've moved that to what do they call that now? SDI and SDO, I believe. So for input and output. So what that means is that SDI. So I believe that's. I believe this is SDI. And this is also SDA. I mean, it's really confusing, I know. And this should be GPO 0. And if this is correct, then is all the only change we need to make. So it's taking this back in. We may need to put that back in later, but we'll start with this. Okay, so it still didn't work.
The serial screen isn't showing up.
Okay, I don't know if I can share two screens.
You're only sharing a window, not your screen.
Okay, I guess I could share my window. Let's do that. For some odd reason, it's lagging really hard. Okay, so what I get is I get BME test, could not find valid BME sensor. Address was 0-FF, which probably means that it didn't pick up anything. So, and this is the settings I had. So D4, D3, D4 is SCL. Which is 2. Okay. Okay, so what I'm going to do for this is I'm going to try resoldering the wires just to see if that fixed the problem, and we will go from there. Or unless, James, you want to try something else before I go changing things?
I mean, if you want to resolder, you can, but I'm pretty sure we can map that out. But if, given that you resolder so quick, go ahead and knock it out.
Well, if you got any
You might want
suggestions,
to make sure you update the address.
Back to what it was.
I did.
Well, no. You changed the pin definition, but did you change the, because you actually have to go into the header file to change the address that it's looking for on the BME.
Yeah, yeah, because I think I got to go into here. Actually, I probably have to go into here to get it, because I think this is where the address is. And unfortunately, the downside of the Adafruit library pack and the Arduino package is that if you need to do anything like this, it's painful. Because I've got to basically dig around and.
No, you can just do let me see here. You're using the Adafruit BME, right?
Yes.
Have you looked at, I think this is where Alex or somebody might have shared originally. But if you scroll down here, you can see how they just do it within the code. You just pass it in the begin for BME.
Do you have a listing, or do you have a link, or what am I looking at?
I just put it in the chat.
Figure out where the chat window is when sharing my screen.
Oh, you would put it in Slack.
Slack works. Oh, I gotta find my window. I have no idea why it's lagging so hard. There's Slack. Oh, here it is.
And if you scroll down past the talk about installing the libraries, you can see the example code that they have that they went with.
Oh, yeah, that's a good question. That's a good answer. So we're using the Adafruit BME 2800, sorry, 280 library from Adafruit for this. Okay, so they included Wire and ESP8266 web server. Interesting.
Oh, that's because they're setting that. I mean, you don't have to, if you don't, since you're not doing that, don't worry about it. But you're using the BME 280, right? It supports passing in.
Yeah, but I might want to include that Wire header because that way I can find the Wire header. Because that was an error recipe last time. It looks like.
You see it in the setup?
Yeah, I think I jumped over too fast.
Yeah, if you
Yeah,
look
so
at the setup there.
There's BME.begin right here.
Yeah.
So yeah, so to make that work for this test code, that's right here. It looks like it's doing 0x76, and it looks like.
Oh, good, Franklin. And Franklin's got a good point on how to fix without resoldering.
Oh, what do you say?
It's in the chat. If you look, I can't remember when you're sharing the screen where the chat shows up, but you should be able to pop it up. Thank you, Franklin. I was trying to remember and I hadn't gone down that path. So you can pass the
Chat. Here it is. Okay, so yeah, so what we'll do is we will go here. We will include wire.h. Oh, it's already included. Good. And then what we'll do is we'll do I believe we do it in this setup. And in this case, it will be technically you should probably rename it, but we'll do it. We'll do it right. SDA. And then up here we'll define
I wish Zoom made it easy for people that were viewing a remote screen to be able to zoom in on sections of screen so that maybe there is a way to do that, but.
is it just tiny text over there?
Your Arduino window is, probably 1/8 the size of the whole screen.
It doesn't help that I've got a really, really large monitor right now.
So
And
On my tablet, I can just pinch and zoom in on his
Oh, yeah.
Arduino code. Yeah.
But doing that didn't help. It's still the same. The fonts are still probably 2 pixels for me.
Yeah. I guess I could. Well, okay. Well, let's see if this works, and then I'll share the code.
Okay. I moved my screen to a 4K window so I can.
Yeah, I actually bought a TV with a. I've actually bought a. It was actually cheaper to buy a 4K TV than it was to buy a 4K monitor for my computer. So I did that. The results have been mixed. Mostly because I discovered that the reason why they have curved screens for computers is because there's limitations on edge viewability on LCD monitors these days. So if I look at one part of my screen, the other side of the monitor is the color diffusion is off. So I can only really use a part of my screen at a time. So it's not as useful as I'd like.
But I'll just say, I don't think those are variables that you can define in the VME library. Or, yeah.
Oh, it's working.
Oh, it is?
Wonderful. Yeah. Okay, so let me stop sharing and I'll share the code, and then I'll share the chat. Well, not the chat, but I'll share the code and I'll share the
So even though I gave you bad soldering paths, you were able to fix it. And
good. Well, which is good, because I mean it's good to know what does an error look like and how to fix it. So do as I say, not as I do. So can you see the code pretty well now? By just sharing that window?
Yep, looks better.
Okay,
Yeah,
yeah. So what we
Actually,
did is we made basically two. Okay, so this is the BME 28 test. You can get there by going File, Examples, going all the way down the list to BME Library and BME Test right here. I think that shows up, hopefully. And for the device, we're using the Wemos D1R1. If you've never installed one before, you'll have to download from the board manager. You'll have to search for and find Wemos in the board manager. And you can look online for how to do that if you don't have it. The default settings should work for this, so that shouldn't be a problem. And so the two changes we made, or the couple changes we made to the code are this BME SLC and BME SDA. And we changed the sensor ID to 76. And we added this Wire.begin before the BME.begin. And what this does is this changes the wire label for what the SDA and the SLC pins are, and we define it up here in our define block. If you use the Wemos pins, those are normally look it back up again. Like for example, if you search for Wemos D1 Mini pinout Arduino, those will be D1 for SCL and D2 for SDA, and that would mean that you wouldn't have to change anything in the code; it would just work. And that's because the Arduino library defaults for the Wemos to those pins for SDA and SLC. But in our case, we changed it because we wired it in differently. And if you do that, or if you just change your pinout, or if you need to do that in the future, now you know how to fix it. And let me share the serial command so you can see it working. For the serial console. Share screen. Share. COM13. Okay. All right. So this is the window going along. So you can see the temperature is 23.86 degrees centigrade. Pressure is 986 HP, which is Pascal, or I think it's HPA is pascals of mercury, millimeters of mercury. Approximate altitude is just an estimation, and then humidity, which is 24 to 25%. If you breathe on it, it jumps up. So humidity definitely works. And temperature should rise as I put my finger across the sensor. It should start going up as it hits body temperature. So at this point, this is when you, at this point, you kind of got a good feel for that it's working, it's doing what it should be doing. Pressure is interesting because it won't change until you actually change elevation. So it should, pressure should be static, except for when a pressure front comes in, like a weather pressure front will come in, and the pressure will change based on that. And so in weather forecasting, a combination of humidity, pressure, and temperature can tell you a lot about what your outdoor conditions will be. For indoor temperature sensor, I'm not entirely sure how useful that is, but it's definitely more useful if these are outside and taking relative outdoor temperature readings. So
Depends on what you're using it for as well.
Oh, you're right. Because I think you can also use this for, if you put this on a drone, for example, the approximate altitude will also tell, you can use the pressure sensor to give you an approximate height off the ground. So it'll tell you roughly like how many meters off the ground you are, depending on how high you are. It should be that simple.
You could probably easily put this in a terrarium to also monitor terrarium statistics.
Oh, good point.
Does the show timestamp do anything?
Say that one more time.
Does the show timestamp do anything?
Is this in the code?
Yeah, it's under the
window.
rectangle.
There's like a checkbox.
Yeah.
Oh, so this is something extra. So this is actually a feature of the COM port window. This is a timestamp. This ties in my system time clock into the COM window. So for example, if you were exporting this, you could use this information to get an idea of when relatively these readings were being sent over serial. So this isn't a feature of the device, this is a feature of the COM application. I believe so normally when you do timestamps, usually the server, I think the Wemos will give it like a relative timestamp, and then the server will use that to give it an absolute timestamp. So it can either report back a timestamp, or the server will just give a absolute timestamp of when it received the message. So in Grafana, for example, it will timestamp the point at which it received the message, which means that the message will be received in a couple of second window, like maybe like a 1 second window between the time it got the data, it packaged the data, turned it into a Wi-Fi packet, sent it across the wireless to a router, got basically packet trafficking, got sent it to this destination address, and then got resoluted into an actual data packet that was then written by Grafana. That usually takes about a second-ish, a couple of milliseconds. And so they'll use that as a timestamp. So for like real-time precision, you won't really get like real-time precision on these measurements unless you get that information directly from the Wemos. But the Wemos also has to take into account that the sensor itself has an internal delay based on how fast it can spit out updated temperature readings. And so in the code, it's not really available to see here. A lot of these readings are actually averaged over a short period of time. So for example, every second, you may be able to get maybe 10 samples. And so they'll average those 10 samples together to give you an average reading out so you don't have as much noise on the temperature and on the pressure and the humidity. So what you're getting on the serial output is actually kind of an average reading, even though it's still jumping around 0.2% or 0.3%. It's really also being averaged internally on the device as well. And that's kind of the limitations of the sensor technology that we have available. So, any other questions?
Yeah, and I think because of that, that's one of the reasons why I switched to the framework I'm using, because with ESP Home, I was able to tell the device to, across the network, grab time periodically so that it could also inject that information with the JSON when it sends it in.
Oh, nice.
And
So it'd
so
be a little bit more accurate that way.
two lines of YAML, and it's got the time from a time synchronized device that the Wemos then has, and it does it periodically.
Yeah. Is anybody else like trying to follow along with this? Does anybody have an example of any questions or on how to get this thing wired in?
So Lawrence, have you used any sorting pen? And I know some pen, like you can use the pen to sort. There's no smell, but I'm not sure about the accuracy. So it might be too thick.
For a soldering pencil?
Yeah, so soldering pencil.
Yeah, so there's different kinds. Let me see what I've got. So I'm using a Heiko brand soldering station, and I'm using a chisel tip. The chisel tip has a wide base and a flat nose. I'm using one that's about, the one I'm using is about maybe 1 millimeter across, maybe 1 to 2 millimeters across. So it's not very big. They have conical ones where they come to a point. The conical ones I don't really like very well because they don't really allow you to have a good soft way to like put the soldering tip against the wire. They also have one that some of the other guys really like as well, and I really have a good soft spot for, is a portable one, which is one of these I forget what they call these things. What am I looking at? James, do you remember what these things are called?
The TS hundreds, something like that.
Yeah.
Or do
These
you have
things
the
are
TS 80?
Yeah, these things are really neat because they're temperature controlled, they're portable, they're lightweight, and they plug into. They're actually programmable, and they're fairly inexpensive. They're like in the I want to say like $70 range, or something.
I think they range between 50 and 100, but it's nice because you can power them off of like a PD USB bank.
Yeah. And so one of the projects I did is I used a portable. I made a battery pack. It doesn't look that great, but you literally can just. I did this for portability, but you can literally plug it together. And then I've got a portable soldering iron. So these also have a temp control. You can actually change the temperature settings. And I believe these came with a conical tip, which is my favorite, but it's okay for most applications. The one thing you'll probably want is the two things that I found really handy if you're doing soldering on your own is a solder flux pin. These things are handy for just applying flux. And I've also used basically kind of like a brass or copper scrubby. You can get these at either in your like your kitchen cleaning supplies, but this helps you clean the tip from extra solder. And then if you get it, I definitely buy lead-free solder. Lead-free solder is a lot more environmentally friendly. And it's a little bit harder to work with, and the temperatures are a little bit higher than the normal. But it's definitely better than dealing with lead. You can deal with lead, and lead's not the world. It's not the end of the world. But it's definitely means that you have to wash your hands, make sure that you can't. You're not really supposed to touch your solder joints after they get put together. And in general, it's not as clean of a system. And the lead-free solder has gotten a lot better than it used to. So I don't, for an intro, I think that's my best example for like an intro soldering kit. The portable ones are just too nice to not have. And the cost difference between that one and the Heiko, for example, I believe is about the same. And the tips, and there's a lot of difference in the available tips. So they sell, I think the tips run like $20-ish, depending on what they are. And a lot of the tips come down to preference.
Yeah, I was about to say my general go-to for at least soldering iron. I'm a little more basic in this case. So I just have some of these Weller soldering irons that you can get basically at Home Depot. This is about a 25 watt soldering iron, and the tips, ignore the tip. This has been well used, but the tips just screw out, and Weller sells a multitude of different type of tips. And so if you need new ones, it's very easy. But this you can actually pick up very local if you want to. And these run about like $15 to $25. So,
And if we ever can meet in person again, I think many of us probably have older irons that we're happy to give away.
yeah, I know I have probably about 3 or 4 of these laying around. So
yeah, I have a crate that I have stuff waiting for the next time we're in person, where I've got a decent Weller station that I'm happy to give a new home. I also, I have a spare BME 280 and an ESP8266. If somebody on here, especially somebody that hasn't messed with this before, wants them, they probably just go in a postage melt envelope and I can send to you. But I've got a few that I'm not. I've got one pair of a Wemos and a BME. You're welcome to if somebody wants one.
Yeah, I think one of the questions we had from the audience is that, are we recording this? And I don't think we are. I don't think.
When I saw that in chat, I toggled it on. I hadn't realized it. So about a minute or so after I saw that in chat, I turned it on. So thank you both, Hong and Alex. I think you all were responsible for even me noticing.
Yeah, sometimes our chats are not as informative. So, so good questions. Anybody else have anything else that they want to hear about or touch on while we're all together?
Yeah, I guess I'm just trying to understand exactly how this is set up. So the ESP8266, right? That's acting more like not only like a programmer chip, but also a Wi-Fi device that's being used to program the BME 280 and communicate with it. And then once it's communicating with the Wi-Fi device, that Wi-Fi device can then communicate with some other computer that you have, right? To grab that data, kind of like that ESP home software that James was showing us.
Yes.
So I guess the advantage of this would be that now your sensor is portable, right? You could move it around different places. What kind of battery or power do you just put, like a coin battery in it, or?
So the Wemos so this is all USB powered.
Okay.
So the weird thing about this is if you really want, so James could probably get a little bit onto. So the main thing about this is because it's only being powered on the 3.3 volt supply or 5 volt supply with a regulator. You can get a lot of options for what you want to do. If you wanted to, you could take a USB power bank you can plug that into this thing, and it'll have a crazy amount of battery life, and that'll allow you to run it for quite a long time. You'll have to look for a power bank that will stay on, even in low power mode. Some power banks will shut off if the current load is not high enough. You can wire in directly a 3.3 volt supply to make this mobile. If you have access to a wall power supply, you can just plug it in directly. So if you have like one of the USB powered or USB pluggable things, you just plug this directly into here. This provides power for this guy. You get a case, or you can just kind of bundle this thing up. You can stick it wherever you want. And that gives you a lot of flexibility for how you can place it. These are really good. I mean, because this is Wi-Fi constrained, you won't get a crazy amount of range. So this will work. So you'll basically have to have Wi-Fi access around your property if you want to put these outside, or in your house if you want to put these around your house. I think the ESP8266 works best at on the 2.8, I think 2.3 to 2.8 gigahertz. So it won't do 5 gigahertz. So, like for example, some Wi-Fi routers have issues dealing with Wi-Fi on 3 versus 5 gigahertz. So this may work best on certain routers versus others. It's been a while since I had to troubleshoot a Wi-Fi configuration with ESP8266s, so I'm not entirely sure if newer ones have the same issues. But there's a period of time when certain Wi-Fi routers would not work as well with these devices.
Alex,
Yep.
I was just going to interject real quick, Alex. It's hard sometimes because we've been using these for so long within this group. It's easy to make assumptions that other folks have too. But these devices have been really amazing, especially with your background. I think you'd find some of the stuff that's been done with these pretty interesting. So, for instance, one of our earlier projects that we did was basically a smart lamp, where it's using that exact same device. There it is. And so he can literally go to a web page that is being served from that chip that he showed, and it's running a web server and controlling that light. And the light, you can't get all that it can do. It can run entire patterns across 32 LED. I mean, of course, I have one here running on several hundred LEDs and doing all sorts of patterns. But at the same time, then you can add sensors to it, and you can have it doing all these other things and still connect to your Wi-Fi and serve a web server. And so it's a pretty high, very, very high utility little tiny processor that, if you order it the right way, you can get it for like a couple of bucks. It's not like it's an expensive device, but we've had a number of projects. Like this is one of my favorite ones that I still use a lot. It's talking to ESP Home, and so before it had its own web server. When we did it as a open source hardware project, it had its own web page, and we could have it scrolling Bitcoin prices and latest news updates. But I've since put it in ESP Home, and I have that right part act as an indicator for events in the network. But they're really, it's amazing. You can go back to a project that you did a year ago and do some creative stuff, but it makes, as far as the stability on the Wi-Fi, I've got a bunch of them. And if there's any device I can just know connects back to my IoT Wi-Fi, it's those. It's the other boxes, like any Google boxes, that I tend to have to reset because they have more issues with the Wi-Fi than my ESP8266s. Of course, it does mean you've got 2.4 gigahertz devices out there. But anyway, it's sorry about that, Alex. I think we're making an assumption. A lot of us on this call have been using them for other things, but they're very, very interesting devices that you can do quite a bit with them.
Yeah, they seem to be a really good way to get portable communication around the house. Yeah, that's really awesome. I think a while back, a couple of years ago, I was messing with a Raspberry Pi 2B, and there's a GPS chip, and with a 10,000 milliamp hour battery pack, I pretty much was running the Raspberry Pi, and it was communicating with that GPS chip, and I just left it in the trunk of my car and drove around, and it was able to. Of course, your cell phone can do that, right? But yeah, that was really cool, and I could see this ESP8266 as being really handy for some projects.
Yeah, you can, if you really wanted to do things that run on battery, the ESP32 has probably a more robust deep sleep protocol that you can engage.
Mm.
And I think the key thing is bypassing some of the other components on that chip or on that board. So that's a broader board that makes it easy to program the processor and power the processor and give you indicators. But a lot of people that are trying to do low power stuff that you would do, like throw it in your trunk and have it run for a long time without having to integrate with your car's network power, you would do things like you could actually use that processor. Like Lawrence, can you show the dev board again? So on the dev board up close, that the shiny part is basically, you can, I don't know if you can see it from the view, but it's just barely larger than that shiny part. And so it's actually surface mounted on the broader development board. So a lot of people, like Travis just disconnected, he's done some really cool things using the bare bones ESP chip and soldering it to do projects, because at that point you can get really low power and run on a battery for months.
Wow.
But the ESP32, it's a more robust box. It's got Bluetooth in it and does some other things. It costs a little bit more, but it can do, if you know what you're doing, you can tell it to go into deep sleep for like, half hour at a time, where it uses almost no power whatsoever, wakes up, collects the data from the sensors, sends it across the Wi-Fi and turns it back off. And then there's things you can do to tweak that process too, so that when it wakes up, it makes certain assumptions about the Wi-Fi, so it doesn't have to do other aspects. So there's a whole group of culture out there about trying to do super low power those devices.
Pretty awesome.
And then there's also I know the ESP devices can get fairly low power, but depending on your application, there's actual controllers that will take up nanoamps, and their whole setup is go into a deep sleep, turn on for a few milliseconds to do some work, and then go back into deep sleep. And they'll run on a coin cell for say 10 years.
Wow.
But those usually don't have larger communication profiles. They're usually just doing something very local, but that's a whole other conversation. So anyway.
Yeah, Alex, I mean, I know this is the open source hardware group, but one of the reasons I haven't done more of the BMEs across the house is because I don't like to have to find a power brick. I mean, you can go with a very small USB device and a small cable and put it out in the middle, tuck it away where it's never seen. But I started using this, which is like about $3, $4 a piece, and they run a year on a coin cell, and it's got open source software on it. And then I have an ESP32 that's in the center of the house that just scans the Bluetooth signal that these put out. That way I'm able to have one thing plugged in, but get sensors for 8 other devices.
That's pretty cool. Yeah, that's one of the problems with Wi-Fi as a protocol, is it doesn't really ramp through the whole use case that people want to use it for. There's not really one. Bluetooth is probably the best example, but even Bluetooth doesn't do long range. We've kind of bounced around different ideas in the past, because we played with like LoRa and LoRa WAN for like ultra long range stuff, and also for example, outdoor sensors. So I guess in the vein of like weather sensors, what you really want is you want weather sensors in different parts of your property. If you've got like an acre of land, you'd like to have a weather sensor by your pond, and a weather sensor by your chicken coop, and a weather sensor by your house. But to do that, you'd either have to, in this case, you'd have to have like a Wi-Fi repeater or Wi-Fi access point at each of those locations. For around the house, it's not that big of a deal. You could have one of these on an outdoor plug next to your house and weatherize it so that it's semi-weatherproof, and that'd be okay. Or you can do, like James described, is have a battery-powered one, but still the range of that protocol, the Bluetooth protocol, is probably like maybe 100 to 300 meters max. So like 300 to maybe 500 feet. which seems like a lot, but every time you have a tree in the way, or you have like a big bush, or you have like people walk past, that cuts down your total range. Because 2.4 gigahertz is absorbed by water. So when you have a walking water bag, like people walk between your device, that blocks your signal. So yeah, I think for our applications as an intro to IoT and an intro to weather stations, I think keeping it in this is kind of where we want to go. If we do another one of these, I'd like to kind of get this tied directly into like a demo weather station, and maybe like a home automation setup. And then kind of maybe like have either 3D printable houses, or maybe some housing we can get offline or online. And then either have a link where you can buy a whole bunch of them, and then have them set up around the house. Or if you wanted to do a slightly easier route, we can go with what James is showing off, which was like a pre-built package, and then use an ESP8266 as a hub, essentially. And then use those devices to have them run the house. So it really depends on where people want to see next, and where we want to kind of go with this.
Yeah, I
So-
think I'm gonna have to go get myself one of those devices.
Anybody try the MQTT on those devices?
That's what I was doing when I was on Tasmota, and that worked great, and it's perfect. And I know that we have some folks that are part of this calls normally that they live on MQTT, and they do everything that way. But yeah, it works great. The library support's really good, but I just did it via Tasmota. But when I migrated to ESP Home, I was able to bypass even doing that. And actually, some people say they see a little bit better speed, or of course we're talking microseconds of the subscriber model of MQTT. You can't really beat that. But no, it works. It's the great thing is all the libraries are there. You don't have to do really any development. And for those of you that don't know, MQTT is a queuing thing for IoT device, a messaging bus basically for IoT devices. And so I know that yeah, a couple people in the open source hardware group spend a lot of time. We've had a talk or two in the past about it, in the way that they're using ESP8266 devices to read sensor data back from their koi pond, and be able to use it to send back rules for their the flow pump and the drain pump to keep the water levels at a certain point. But we need to get him on here and get a little bit deeper on that, because it's amazing. If I listen to him all the time, all I would do is MQTT, but luckily he skips that occasionally. Hey, Brian, good to see you, camera. I always like to call out people. Franklin knows this. I see him every couple of weeks, and I try to minimize, especially on the weekend, my abuse about having the video off, especially when I'm not the one running the meeting.
Well, I was heads down doing a little soldering. So
did you get it done?
Well, we'll find out. I was just adding the support to the Arduino IDE. So
okay.
So as far as I know, I got it done. So
Gotcha.
I appreciate James, you and Lawrence, well, and everyone who's taken part. Robert, you as well. But thank you for sharing. This is I do some smart home stuff, but haven't done my own hardware. Just off the shelf stuff. So this might be fun. I do have a fair number of devices around the house, but you have limits on what you can do when you're buying someone else's rig. So it's kind of cool that you can do your own and what fits you. A koi pond. I'm not sure if there's any specific koi pond sensors out there. So being able to do your own is pretty cool. So
yeah, he has like ultrasonics that are hitting the surface of the water to figure out what depth it is, and based on how far the distance is, he either opens up the flow or opens up the drain, I guess. But I'm not sure. But it's amazing that what you can do if you go off the ship. Take some of these ESPs and throw them together with a couple of sensors, and you can tackle quite a few different issues.
That's super cool. But thank you for sharing. And it's good to see you too.
Yeah, it's good to see you too. It's been a while.
Actually, yeah, this has actually been a little bit of a project that I'm going to have to do myself, because it's kind of been in the back of my brain for a couple of years now. And it's just, when I first saw it, it was basically the $6 weather station. And not so much using the Wemos, but using a standard ESP8266 board, a power converter, and the BME 280 sensor. And they were able to find them at low enough prices you could build the whole thing for less than $6. And some of that is if you don't mind waiting.
Yeah, yeah. I mean, in fact, Lawrence, Lawrence has, there was, like he mentioned, he's got, man, I'm amazed how many Amazon boxes you got, man.
It's a problem.
But we've used the ESPs for so many projects, whether it was the robot or the marquee clock or the lamp that I think he's got some that the group has for future projects. And so maybe we could start to source them again. One of the things I'd like to do when we have a chance to be in person again is I've been creating a massive parts bin spreadsheet of all the things I get. Like, oh, it's cheaper for me to buy 10 of them and I only use 7, and so I've got 3 left, and that's why I'm sending off I'm sending off my spares when I get a chance or find somebody that can be inspired by it, because I used to keep a Wemos always in hand or in my pocket, in my backpack, and so I don't know, I think almost for about a dozen different open source hardware meetings in a row, I would make sure somebody went home with one. And I'll tell you a guy I gave one to in Wisconsin. I was on a business trip. He ended up getting so inspired by it that he actually built an open source CNC. I mean, obviously that was his gateway drug. And so now he has a open source CNC device he's built, and he's building a makerspace up in northern Wisconsin to serve a community. So I thought that was exciting. But yeah, we've got a bunch of those parts. So Lawrence, I don't know if you've got a model for those that don't want to wait on the ship, especially since we're going into January into the Chinese New Year. Of course, Amazon's finally picking up some of these Wemoses at a reasonable amount. I mean, they were about $5-6 a piece, and that was a bit too much when you could, if you were willing to wait a month or two, get them for $2. But
I got them for roughly $15 for 5 of them, so $3 each. Yeah. And I got the little sensors. I think they were $6 for 5 of them, if I'm not mistaken. And they're prime. So yeah, that's pretty cool.
Oh yeah. I don't know if you're on that for this discussion previously, but we ran into a whole bunch of issues with the BME versus the BMP version. The BME is the one that we used. And you also have to be careful because some of the listings on Amazon, they kind of confuse the two. But the sensor we used was a BME 2080, I think.
280.
280. And that one has the temperature, pressure, and humidity sensor. The BMP, which should be less common now because I don't think anybody uses it as much, only has pressure and temperature, and drops the humidity feature. So that was kind of a trip to figure out what was going on.
Happy cat.
Any cat.
I was gonna say, Brian, I can't believe you got those prices. I need to look at Amazon again because, man, I get tired of waiting on the ships and
yeah.
Yeah,
these came second day from Prime, so it was really fast.
Yeah. Yeah. If you get it plugged in, let us know. I'd like to see somebody else with some success. If you got it.
I will share.
Do you have plans for how you're going to integrate it? Like once you do it with the Arduino and see everything's working, next thing you want to do is either do it all locally and make it like the examples that are out there as being its own web server and showing the data, or are you going to integrate it into a framework that you've got at your house?
I don't know yet. I'm still using standard smart things. I haven't made the switch off to something more local at this point. So it is most likely coming. There just hasn't been time.
Gotcha.
There's always not enough time for all the fun projects. So
Yeah. I'll tell you, I was on Wink, is that what it was called, for years, and then they decided to go to a subscriber model, and so I'd already gotten a smart thing, so I was able to migrate my Z-Wave instead of trying to figure out how to do that all open, and I just integrated Smart Thing with Home Assistant, so that way I can use. I'm a big data guy, not big data, but I like to have the data as it's an ongoing joke. I can graph like the temperature and the humidity and the pressure for 18 different places, and no reason to, but I can. But my point is, now I can have like the sensors that are on Smart Things and everything. It all feeds into Home Assistant, so I can do some really cool automations. So if you ever want to talk about that, Brian, happy to. I think some of the people in this group get tired of me talking about Home Assistant and ESP Home for them. But
well, I'll be an open ear for you, because I'm very curious.
I don't like to. I'm not a very good programmer in the first place, and so having to revisit the code that I did poorly, a few months ago, got old, and so that's why I started migrating everything to ESP Home, just so I could have some YAML that I can make minor changes to over time, and have something I can have in one place. And the neat thing about it too is, I just have a super long USB cable out from the back of the I had on a Pi, but now just a VM. And so whenever I have a brand new device, I just plug it in for the very first time to get the base firmware on there. And then anytime after, I can just do it. I'll do it over the air.
And the base firmware has your Wi-Fi and your SSID information.
Yeah, and there's a fallback too. So like whether it's Tasmota or whether it's ESP Home, most of them, even if you go through the Arduino, if you wanted to, like I know Alex is a programmer, and so one of the things that's really cool from the ESP for the libraries for the ESPs is there's a Wi-Fi manager where you can just have it tackle handling the Wi-Fi, and even it will stand up its own as an AP that you can connect to.
Oh.
So you can connect, if you didn't want to put your credentials in it, you can have it stand up as an AP and then give it the credentials to connect to whatever wireless. So it's funny, whenever we bring our devices to the open source hardware events, they don't connect any Wi-Fi, so they all go into fallback mode. And so you have all these different ESP devices broadcasting their own SSID. And so everybody's trying to connect into their own and configure it. And so we had to play nice to each other at one of the meetings because we're all building robots. I think I found mine. He's up. Forgive me. Let me grab him.
I actually never got to build one. I was kind of disappointed. I spent so much time helping everybody else build them.
I missed out on those meetings, unfortunately.
Yeah, so we built these guys, and it was funny when we finally all turned them on. Of course, you had to reassociate them with the Wi-Fi, and I think we had a dozen different SSIDs, and so you'd connect, and you had to play nice. You couldn't give somebody a bad password. But anyway, there's a lot of great frameworks out there to make it easy to do that. And then, of course, from an open source software perspective, a lot of these devices you can buy. I think Robert was showing one right before the call started, but half the devices that are smart, you can actually man in the middle and put open source, put Tasmota on it, for instance, and have it integrated, and not have to talk to the cloud. So I've got power strips. There was a deal a couple of months.
Yeah. So basically the little smart outlets that you can get. This one is a Fiat Electric. Yeah, from Home Depot. So it's compatible with Tasmota. So there's a lot of stuff that's just off the shelf that is supported. You just have to put different firmware on it. Anyway.
The great thing,
haven't gotten there yet.
Like, let me see here. You mind if I share my screen again? I don't want to bore you all with Home Assistant stuff.
No, go ahead. I'm basically done at this point, so we can basically wrap up whenever we want to.
Okay. Let me see here. So my Home Assistant, I manage stuff, in containers too much on other projects. So I don't have headaches on my personal stuff. So it takes care of all these for me. But I actually have one for managing Tasmota boxes because I still have a few. And so it was really easy to take a off-the-shelf box. Oh, just a second here. Can't remember. Just a second here. Can't remember. Just a second. It's been a while. There's a lot of these things. Okay, here we go. I'll just bypass the management. So for those of you that mess with Tasmota, this will look familiar to you.
Mhm.
So the cool thing is these little boxes, they were on Amazon for about $5 a piece briefly, but normally you can get them for about $10 a piece. They got 4, they're called KMC4s. They've got 4 outlets that you plug in. It covers your regular outlet and it opens up 4, and 3 of them are programmable. And the third or the fourth is on all the time. And
How did you get a power factor of 0.66? What are you running on this thing?
oh, that one has a UPS on it. So this, let me go to this one instead. This will be better because this is actually off right now. But so this made Christmas lights so much easier this time. So I plugged this into the wall and I got brand new LEDs for the first time for the whole house, and my daughter helped me put them up. And so I wanted to get it right where I could just have it programmed. And I ended up not really even turn them off, but 3 of the ports were programmable. And for the first part of the holiday season, I'd turn them off at night automatically. But I was able to collect all the data. So it was really cool. I was so glad I kept the 60. I actually have an old lamp that I still have a real bulb that I know uses exactly 60 watts. And so I was able to I was actually able to calibrate the Tasmota settings so that this $5 device that it's like works. And so the cool thing is you just take a Raspberry Pi and man in the middle, and you replace the firmware that's on the ESP that's built in from the manufacturer, and then you can run whatever code you want. And so one of these I had, I was running Tasmota forever, and then I decided just to do a firmware upgrade. And instead of loading Tasmota upgrade, I loaded an ESP home firmware. And so without ever having to touch the device or reconnect it, I converted my BME from being on Tasmota to being on ESP home.
Oh, very nice.
That's pretty handy.
Yeah. It worked. I mean, it's work. I mean, there's something to be said for using your own code and doing some really cool stuff there. But for those of us that deal with tech all day, it's kind of nice to just build on what somebody else has done.
Definitely. So are you managing your containers with Kubernetes or Docker Compose?
Well, you know, I harassed you about the Kubernetes, about a year ago, Brian?
Been a little while, yeah.
But I do have a small local cluster I play with, a stack of pies that are a 4 high, but I have a VM that's got all these various containers I use for other stuff. But then almost everything associated with managing my home is done as a Docker container in Home Assistant. And people have already done all the add-ons. So it manages the upgrades and the logs centralizing and the tie-ins between the database container and other. So I had here, I'll just pull it up again. So from the supervisor, you can see I've got a UPS that's hooked up into my VM or into my, that pass through to the VM that runs Home Assistant. And so I'm able to gather all the attributes associated. So like entities for everything associated with power created, like here. Why is my shortcuts not working? Well, like I even moved my Nginx proxy manager to my Home Assistant. So my home IP address, based on how you hit it, it's name-based mapped, and it automatically handles my Let's Encrypt turn up. I have Portainer just to have a different view of some of it. Sure. I've got my Node-RED that does a lot of the automation. And then, Tracker is like, been playing with this with the phone devices to be able to, it's a MQTT based it's actually a lot of companies are beginning to use it. It's an open source GPS tracking. So I load a client on my phone or my kid's phone, and it lets me know, where they're at. Of course, my Home Assistant even serves as my WireGuard host at this point.
That's pretty cool.
Yeah, I don't. And the cool thing is, I just deal with, like, most of these only have 4 or 5 lines of YAML associated with the setup and the management of them, and I set it and forget it. So, like, the database for everything is a MariaDB right here, and then I've got Influx and Proxy, Grafana all managed there too. So I can just come into, let me see here. Like Grafana and the Influx are all built in here. And that way I just use Nginx to pipe back. Actually, some of it actually manages the front end for it.
Yeah, that's cool.
Anyways, it really makes it easy to have too many toys. So,
could you talk more about how you track your kid's phone?
So yeah, Tracker is the open source project, and I've got clients for iPhone and for Android, and so it's just all it does is share the location. And let's see here.
OSTRACCAR.
Yeah.
Okay.
So here's my daughter. It says my daughter's right there. I'm at home. I turned mine off because the Home Assistant client software, it's open source that runs on iPhone. It also has tracking. You can opt to have it share that information. So, like, I come back up here. So I've switched mine to it. I think I may stop using Tracker just because it's easier. Once you load the Home Assistant client, it's really cool. And this goes back to something Robert was showing. It's easy to bridge your old smart home and new smart home stuff. So, like, I have pretty much any device I have here, I have all but a subset is automatically integrated as devices on Amazon and Google. So if I'm going to use the Google framework, like a Google Mini, I can automatically have it gateway it back to the equivalent device on my Home Assistant network. Or so, like, I'm sure everybody has gotten one of these at one point. If you're super paranoid, but the free or the near free smart ones for Amazon that only work on Amazon. Well, yeah. If I tell Home Assistant to control it, it does, but it gateways it back to Amazon seamlessly.
Oh, cool.
Let's see here. Just to give you an idea of some of the data that's kept. So, like, if I look at UPS, these are all the entities in Home Assistant. Oh, let me go. Here's my Pixel. My phone is a Pixel 3 XL. And these are all the attributes. I'm a data freak, right? These are all the attributes that it's collecting constantly from my phone. And it comes in all the time and only into my network. And so, like, I can actually, like, over time, I can see exactly what alarm levels have been set. It's like silly stuff, but like, so you can see I turned it down or something, I guess, but let me see here. But from a tracking, back to what Hung was saying with the tracking, I can say, let's say location. So there's her location, but here's a geolocated location. So now you know where I live. And so you can see I left earlier today to get oil changed, and then I ran around last night. I haven't gone anywhere. But anyway, it's just neat because it's all self-contained. I mean, it does set up an encrypted connection back to my home to put it into Influx, but all this data is automatically captured. And so, like, the BME, everything just becomes an entity that I can use in other automations. Gosh darn it.
Yeah, the other cool thing about Home Assistant is that it uses containerized web servers for everything. So you can actually have all these different devices, all these different interfaces on different servers if you wanted to. And Home Assistant itself, I think, containerizes all the different instances. So what it turns into is it's basically just like a dashboard of dashboards. And so it's just a way of collecting a whole bunch of different data from a whole bunch of different disparate devices, and then displaying it in a way that makes logical sense. And then to be able to do things based on that information using scripts and JavaScript to control different features of your different smart devices and devices producing data.
Just a second.
So do any of you use Zoom professionally? Anybody? Nobody uses Zoom professionally? I'm just gonna say, because of all the integration that he was referring to, I've got, of course, several of you I can't even run. The cables are all running, but that lamp that Lawrence showed, that column lamp, whenever I'm in a session, I have two of them in the house, and whenever I'm in a Zoom session, it turns bright red, like the first half. The lamp turns off, it turns back green, and then when it's not working hours, it goes back to whatever full pattern it was. And it's entity Zoom status where it talks to the API to get that, and it was within Node-RED. So it integrates a cloud service into and back into into 2 or 3 different WD devices that are tied together.
You have a link for that lamp?
Yeah. Let's see here.
Do you want one?
Of course I do.
One of the first big, I guess, quarantining projects we did was 3 of us 3D printed all the parts, a bunch of lamps, and ordered so a lot of us went home and built them.
Oh, how cool.
And so what he's saying, he's got spare parts.
I think we had 15 originally. I think we've sold like 12 to 13 of them at this point. And I think we've almost broken even.
All right. Well, maybe I can help throw you over the top. Maybe if I can Venmo you a little cash or something.
Sure. Do you have my information on Slack?
I don't.
I'm Loki on Slack, or if you've got my name, it's Lawrence. Just hit me up and I'll work out a time and details for cost and what we have available.
That'd be great.
And also shoot over the instructions as well, because every time I do this, I learn one more thing about what I forgot about 6 months ago.
But basically, I mean, some of these projects is simply that Wemos developer board and something else, whether it's a single sensor, a single LED, a single 8x8 matrix. All these projects is basically 4 soldered wires and then the code. So like I just sent the link to what 3D printed, and I think Obadiah made a different insert that worked better for the LED count that we used.
Mm-hmm.
And so you basically got all the parts, but if you wanted to do it, you just Wemos a strip of LEDs that's about 30 to 32 LEDs long, and then the cool thing about WLED is somebody wrote really good integration with Home Assistant. It actually detect network, you know, the API in, and all of a sudden you can feed it all sorts of light patterns. So like, you know, do cool integrations. Like if no phone is in the house, turn all the LED lamps off, you know, stuff.
And there's so much to do and so much to learn. It's awesome.
Yeah, that's what I do at night when I'm, you know, goof off when something inane is in the background on, that I do not want to be part of. But yeah, it's fun. Anyway, so be looking forward to seeing everybody's temperature sensors and pressures.
Yeah, and
I haven't figured out. What's that?
I was just going to say that just surveys, the latest link that's on the meetup page, it includes a display, which we don't currently use, although the display is kind of cool. But any BME 20 or 280 and the Wemos was basically what we're using. So.
So
Awesome.
I have a quick question. Franklin, you were sourcing. Have you got some project working on? It sounds like you've got some experience in TT.
I really have. I was working with bigger board like DF. This is a DF robot board, and here mostly those sound. And I have here the. This is for like vibration, those type of things. But in normal time, as we know, there are a lot of other projects in agriculture that I'm working on, mostly with the soil humidity and moisture and NPK content and things like that.
Oh, okay.
Yeah,
Well,
those-
the reason I'm asking is it's so that maybe we can wrangle you for a future discussion lead.
yeah, pretty much. I mean, it's what I use is I have this board, this kit sitting that I use most of the time. As you can see, all my accelerometers and things like that. Then I have not used the ESP and 8266 that much. I use mostly this bigger board. I would love to kind of play with those small board too.
Well, we'll get you hooked up. It's fun to play with. It's amazing.
Yeah. One thing I really love to do, I thought you said that Alex is a programmer, is to use things like state machine for more like dynamic and automated types system that you program by yourself, depending on what's happening. Instead of just entity cube may be good, but at the beginning, if you have to build your own firmware in like Arduino in such a way that you have different state that you want to play with, depending on what is happening in the environment, you may want to do a certain number of things. That state machine works well for that, right? A finite state machine can work well for that. And I'm really interested in seeing how people are playing with those type of techniques.
Yeah. Well, hopefully we'll get Alex hooked up with some devices too, and he'll go nuts. Right, Alex? Chris, have they officially done your swearing in for Techlahoma board member yet?
We got the kind of like oh man, what do you call it? Crash course, I guess. That was a late December. I think the first session will be the second Tuesday of every month. So I think the first session will be the 19th. Actually, I guess it is every third Tuesday.
Well, we're just happy to have congratulations for the board. And, happy to have you join us on a Saturday like this.
Yeah.
It would be great to have it on the Saturday because during the week it's so hard to be there.
Yeah. Yeah, definitely with work and everything else. I think Saturday is a good time.
Yeah.
Yeah. Well, I do have to go, but I want to thank
Yep,
everyone for this time. I think I learned a lot, and I'm definitely going to buy one of those. I just call them ESPs 8266. Do you guys have a shorter name for it, right? I think.
That's the dev boards have names, and so there's like the KnowU and there's the Wemos D1 Mini. And I think most of us use the address, Alex, and I'll just mail you one.
Oh, okay, sure. I'll reach out to you on Slack.
Okay, or maybe faster if you Amazon with what Brian did. It's got on the name.
Yeah, I'll definitely look for that. If I can spare a few bucks, but
Lawrence, you want to wrap things up? I guess I didn't realize it was already 4.
Yeah, sure. We can wrap it up. I guess I guess we'll talk on Slack what we want to do for next month. But we'll probably do maybe continuation, maybe make a case, maybe talk about integrating this into Home Assistant. Or we can move on to whatever other project people want to jump into. But thank you for everybody for your time. It's been lovely. I think we've got this recorded, so hopefully we'll get this on YouTube. And I think with that, I'll call it a day.
By the way, so will you just put it all for the video on YouTube or just part of the video? I think there's some private information on later of the video, like the address of James,
Yeah,
something like that.
yeah, we'll cut off the video probably just for the, we'll probably cut off the very beginning and the very end, and just leave it for the demo phase, and then we're talking about the integration portion of it. The home assistant, basically everything after we got it working, will probably be cut off.
Yeah.
Okay, cool.
Thanks for, I
Thanks.
have a habit of being a little bit too open. Great seeing you.
Awesome.
Thank you.
Thanks, everyone. Bye.
Thank
Thanks,
you. Thank
everybody.
you, everyone.
Thanks
See
for
you,
sharing.
James. Bye.
Bye.